Welcome to the webinar on open close principle. My name is Yasub Hashmi. I'm working as a Agile technical coach and I coach teams, individuals, and organizations on their journey of being technically agile. Uh, this webinar is a series of webinars which is part of the Bangalore Auto meetup group. And this meetup is actually moderated and run by Spot Agile community. It's a community of agile practitioners uh, who love to learn from the community and contribute back to the community. So as part of the community, there is a LinkedIn page. Here's the link that you can follow, and the recording of this webinar would be going back to the YouTube channel, which is again another Spot Agile YouTube channel where you can subscribe and get the recordings of the webinars that we conduct. And you can follow the channel and you can follow LinkedIn. So that's about me, about the community, about the YouTube channel. Let's come back to today's session. So before we get into open close principle, actually, let's see from where is it coming. So open close principle is part of the like a big principles, like set of 5 principles, which is like this, O, and ID. And when we talk about these principles, we talk about more about like how do you design your system so that it is scalable, it is ready to adapt to the changes that are coming and the business changes that come on a daily basis, and then with those changes your existing system does not break and your design becomes emergent. And another way of saying is that how do you make your design more testable. So we talk about testable design. So all these things which I spoke, solid principles is one of those things that will help you to achieve these things, which is emergent design, which is like testable design, which is a design which actually allows you to scale. So today we're talking about on the second principle, which is open close principle. The first principle, which was single responsibility principle, we spoke last time, and there's a recording available on YouTube channel, which you can go and watch. And soon the recording of this session will also be available. So let's move and see what is second principle, which is open close principle. So open close principle, it says that you should be able to extend behavior of a class without actually modifying it. Or in other, the other definition or in other language, you can say that software entities which are like should be open for extension but closed for modification. It's like a couple of times or 3 times I've repeated the same definition or maybe similar definition in different words. But what exactly it means? Let's get into the code. Let's be technical and see how actually we achieve this principle rather than just going through the PPTs. So here what you see on my screen is a very simple code which I have written. It's very simple, very lightweight, because the purpose is not to actually get into like a complex code and understand the complex domain. The purpose here is to understand what is open close principle. So what I have chosen is that we are trying to build car booking or car rental application, more like Ola or Uber, wherein you just book a cab and then you pay for the ride. So out of that big application, one of the things that I've picked is that how do you calculate the fare between start point and the end point. Let's say you started somewhere from one point and then you had a location. And then based on the total distance which is covered, how much fare should you pay? So you see I have a very simple class here which is right fare calculator, and it calculates the fare. And I have intentionally created 2 multiple calls to this one so that you can see that how differently. Let's get inside this function. What exactly it does is that it takes the start point, it takes the end point. It's like location A and location B. Location A is the start location, location B is the end location. And in real world, maybe we are hitting the Google API to get actual distance, but here for the sake of simplicity, we are just simply saying that So I was talking about that. How do you calculate the distance? So in this case, we are just simply saying that the start point was like 5 and the end point is like 3. Then how much distance you have. So maybe like 2 units of the distance, 2 kilometers, 2 miles, or whatever it is. And then how do you calculate the fare? Is like simple, like 3 units of distance multiplied by 20 units of money. So like rupees, dollar, euro, whatever it is. just run the application and see what the outcome is that. And what we see is that the total fare for a distance of 2 units, which is like 2 kilometers, 2 miles, or whatever, is 40, and the total fare for a distance of 3 units is 60. So we are pretty good. We have covered the functionality, whatever the requirement was, we have achieved it. Business is going good. Business is saying that we are doing pretty good, but then the thing is that uh, we are doing a standard calculation right now, and standard calculation is like we are always multiplying with the unit of 20, which is like 20 euros or $20 or 20 rupees or whatever. But then now we are expanding our business and we are having the different types of cars. So this fare works fine for the standard car, but not for the sedan. And sedan is the new addition that we are having. So business comes and says that, hey guys, can you actually do the calculation differently for different kinds of rides for different kinds of cars? So one of the ways that we could do it is I'll do it right away and let's see. So I'll say, okay, now that you need the different types of cars, I think it's a good time that we have some car instance created, which will actually define that what kind of a car it is, what is the car type. So I have created this car, kept it ready, because it was a pretty simple one, and I didn't want to waste time here. So I just created a car class entity, and it can have multiple properties like registration number and the who's the owner of the car. But we right now at this moment we don't care because that's not important. And there is an enum type which is car type, and says that there is a standard car type and there is a sedan type, which this car is of type. So what we do is that we go here and we say standard car, and we say name of a car, and we say the car type is equal to car type dot standard. Okay. And let's give another car which is sedan car, and let's say car, and let's say car type is equal to car type. Now that we have the cars, but then the fare calculator does not really know that for which car, what kind of a calculation it has to do. So let's go and modify this class and say, hey, you know what? Let's have the car instance passed here, and if the car type is equal to car type dot standard, then I keep the same calculation which I had initially. Else, if car type is equal to car type dot sedan, let's have some other calculation, and let's say sedans are pretty expensive, so let's say instead of 20 units we say 25 units. And then what we do is that now this will start counting more parameters here. So we say, okay dude, you are a standard car and you give me the calculation for a sedan car, and let's run the application and see what happens. So hopefully we should have different rates for different types of car, and we should be able to see. So the total fare for a distance of 2 units is 40, and if you see for 3 units instead of 60 now it is 70. Somewhere we can include a message saying that total fare for a standard car for a distance of 2 units is 40, and total fare for sedan car for a distance of 3 units is 75. But then let's not do that. The beautification is not important here. Okay, so we covered the next business functionality which business asked us. Business is once again happy, and then they're doing good, and business comes back and says that, hey, so you know what, standard car is good, sedan car is good. Now we're expanding business further. We are actually launching big cars, axle cars, which are like kind of 7-seaters, and we might want to do a different kind of fare calculation for those cars because they are more expensive than sedans. Okay, so what do? I follow the same pattern. I go back into this one. I introduce another if else condition. I modify this class, and I continue doing this until they are like having like 20, 30, 40 types of cars. And then at some point of time, you will see this class is growing bigger and bigger and bigger, and having more and more business logic here. And then what might happen is that eventually that I might want to reuse the code, or I might want to actually do some modification which might break my standard car type of calculation or sedan calculation, or might something different, or maybe everything, because something might be common in between. And that is actually not good. We don't want to break the existing functionality by adding a new functionality. That is not the intention. So what I would like to do is that once this class has some behavior written in it, I don't want to touch it once it is gone to the production. I don't want to change the existing behavior. Rather, what I would like to do is that I would like to extend the behavior in some different form, which we will see now. And how do you do that, or how do we do that? Let's just do it right away. So what I'm going to do is that, for the sake of simplicity, I'm going to a new project, and it's a class library. Say, car booking library, and I would say this is the implemented. So I'm going to create a new uh, library, and actually convert this default class into a array. And interface, and I would say public interface, and I would say I pair sure. And I would say one method here, I would say pair, and I would say I would keep the two parameters as it is. I would say start point, and I would say int end point, and I have the interface ready now. And then what I'm going to do is that in the new library that I just now created, I'll just rename the class name also so that it looks good and it's obvious. Okay, we are good now. So what I'm going to do is that I'm going to add a new class here. Let's say standard or here q.cs. And what I'm going to do is that I'm going to extend in .NET language. I will say implement the interface, and let the IDE do the work for me. So it implements this thing. And let me actually steal the code from the existing one. I'll just simply copy it and stuff, and I'm going to delete it. So I'll just do this thing here, and I'll say I don't need you, I don't need you, I don't need you, and there we go. So now we have a standard car fare calculator. What we are going to do is that we are going to comment this code out because we are doing it different way. So what we will have is that we create an instance of the newly created class. Let me add a reference of this guy. And then I would say all right, ID, just give me a solution. Oh, didn't pick up, sorry. Maybe I made some mistake. I'll just copy this. It's the easiest thing. Student, but I know why. Because it's not public. About now. Yep. So now I have a standard fare calculator, and I say standard fare calculator calculate for the same distance, which is like 2.4. And I don't need a car instance now because I don't know differentiate based on this one. And then I just run this application just to make sure that everything compiles and we are back to where we were originally. So total fare for a distance of 2 units is 40. So we have the standard power. Let's implement the sedan very quickly. I'll just copy this code so that it can quickly do sedan power fare calculate. calculator.cs. Here it goes. Implement iFair calculator with the ID of the job. It does it. I take this thing directly from here, copy it, go back there, paste it. The ones are expensive, so it's 25. Go back to the client, create an instance. Set on car calculator is equal to set on an instance, take identity public, insert it like that, and okay, there you go, and I say calculate fair, and I do 2.5 here. Okay, let's see if we are back to business where we left, where we said that OCP is everything. Oh, see, so for 2 units we have 40, for 3 units we have 75. So we are at the same stage where we were here, and we said that we want to extend it for the Excel type. So by now you have observed that what I'm doing is that I'm creating the new classes here, and each time I create a class, I just implement the same iFair calculator, and I'll do whatever the logic that I want to put it for this specific standard car or whatever the car type I am having, and for the different car. And I do, when I created the sedan car fare calculation, I actually did not touch standard car calculator. In fact, there is nothing that overlaps between these two. And once sedan is live, is in production, I do not touch standard, or I don't want to play around with that one when Excel is coming in place. So similarly, I mean, I can go ahead and create another class here, which will be like Excel, and then I can change the rates there, and then I can have that's pretty much like about the open source principle in a very simple example, very lightweight example. And we can keep on creating more cars, like mini cars, more macro cars, and then different types of it. And then what you see is that based on the type of the car, we are just implementing that interface. One of the things that you could observe here is that you might come back to me and ask me, hey, so you know what, you said that we should not be modifying the code, existing code, but then you are keep creating the instances here. If there are 2 more types of car, then you might create 2 more instances here. And how about this purchase? So a couple of things here is that one thing is that in a real thing, we will not be actually creating these instances just like this, like we are doing it here. It would be something kind of like input from the UI, and based on the UI input, you might want to choose that what kind of instance you need, and every time you might want to get the instance of iFair calculator, and that you can resolve using the strategy pattern or any other design pattern that fits your need. So that way you might even reduce this code, and you might make it simple. So this is one of the applications or one of the examples that I have shown you about the open close principle. The other areas wherein it could be implemented is that a couple of things that I have in my mind, which I can very quickly tell you based on my where we have implemented. Just imagine that you are having something kind like Windows-based application wherein multiple versions you have to support. So for an example, you might have a version of Firefox on your machine which is like 10.0, and the other machine might have 11.0, and then you might have hot fixes in one of the versions. So how do you go and how do you do it? Do you actually go and change the same class and you say that if the version number of the my product is 2, then do this kind of a thing, and the version number is 3, then do this kind of a thing? Then you're making your code messy and you're creating a problem for yourself. Maybe rather you might want to create something like this, which is like having the interface, and then you keep on extending using the versions and the hotfixes. Now, once again, this is one of the ways of doing it. I'm not saying this is the only way, but you can do that way. The other place wherein you could have this OCP principle implemented is that, once again, based on my experience, is that we were having multiple vendors which we were supporting, and for each vendor there was a different code that we had to write, different behavior that we had to support. It was a need of the business, and that's the way we had to do it. Now, once again, you might want to go and say that, if the vendor is equal to, say, IBM, then do this thing. If the vendor is equal to uh, Tech Mahindra, then do something like this, and keep on doing that thing. So once again, you will make your code messy, and then more problems might come. And once again, how would you do it is that create an interface, implement uh, those things, and keep creating different classes for the different vendors. Those are the two more applications that are there. On a closing note, I can say that with open source principle, you will have very smaller classes which would have very minimum code, which will eventually uh, complement with your single responsibility principle, which will make easier for you to maintain your code. But at the same time, it's there for everything. Like, if you overdo that thing, then it might come back to you, and you might have like code scattered everywhere, and you might have to maintain. So you might have to maintain a balance about how do you go with the OCP.